We are finishing up Unit 5D. We've got page 26 and 27 to go, so hopefully we'll roll through both of those in this video. This is another example of our nifty way to create a quick graph using the x and the y intercepts. This is what we did on page 25, and I've got another example here. Again, I draw a t-chart, and I put the x-intercept at the top of one column and the y-intercept at the top of the other column. Remembering, when we are trying to find the x-intercept, we're going to let y be 0 and figure out what the x has to be for the point. And the opposite, when you're finding the y-intercept, you're going to let x equal 0 and solve the equation. So our equation is, okay, now I'm back. X plus 2y equals 4. We're going to let y be 0. So 2 times 0 is just 0, and x equals 4. So our ordered pair is going to be 4 is the x, and we let y be 0. So that's one of our points. The second point, go back to the original equation, x plus 2y equals 4, and we're going to plug in 0 for x. So that x goes away, and we get 2y equals 4, or y equals 2. Write the ordered pair, x is 0, y is 2, and now we can go over here and we can plot our 2 points and thus create a line. 1, 2, 3, 4, 0, and 0, 2. So we know our line is going to have a negative slope. It's going to rise, start rising and fall as it goes to the right. Okay, so let's look at this example. So the question's asking us, why is it not possible to use these intercepts, the x and y intercept, to actually graph this equation? It is kind of an interesting equation, and it does show you that some of the times, not very often, but some of the times using the x and y intercept doesn't work. So let's give it a try. X-intercept over here, y-intercept over here. So x-intercept, we're going to let y be 0, y-intercept, we're going to let x be 0, and we're going to go plug those values in our equation. So our equation is 3x plus y equals 0. I'm going to plug in 0 for y, so I get 3x equals 0. Divide both sides by 3, and you get x has to be 0 also. So our ordered pair would be x is 0 and y is 0. Okay, let's go try to find the y-intercept. Start with the original equation, 3x plus y equals 0. Plug in 0 for x, which wipes out that 3x, 3 times 0 is 0, and we just get y equals 0. So our ordered pair is x is 0, y is 0. Well, look at this. Both of these intercepts are 0, 0. We need 2 points to plot a line. We've only got the origin, which happens to be where this line is going to cross both the x-axis and the y-axis. So this is not going to work. The intercept method is not going to work for this equation and any other line that goes through the origin for both the x and the y intercepts. So the question in part B is, well, what method could we use to graph this equation? So my thought is, let's just use the slope-intercept form. So we're going to rewrite the equation in slope-intercept form. Remember, slope-intercept is y is equal to mx plus b. We already have a pretty good idea of what b is. We know where it's going through the y-axis, right at the origin. But let's go see if we can figure out what the slope is. So in order to get it in slope-intercept form, 3x plus y equals 0, I need to subtract 3x from both sides, and we end up with y is equal to minus 3x plus 0. So from this form, we can pluck off the slope, which is minus 3 over 1, and we can pluck off our y-intercept, which is b, and it's 0. So we can go graph it now. We know that it crosses the y-intercept at 0, crosses the y-axis at 0, We know it's got a negative slope, so it's going to start high and fall. We're going to rise up 3, 1, 2, 3, and run 1 to the left. 1, 2, 3, and then we can go down and pick up some more points. Go down 3, over 1, over 1, and then you can draw a line through it. Better than me. So that method worked. The intercept method didn't work. It doesn't always work, but when it does, it's kind of cool. One other problem I'll tell you that I have with the intercept method, I like it a lot and I use it a lot, but you're only finding 2 points. So notice on this example, we had these 2 points that we plotted and drew our line. On example 4, on the page before, we had 2 points we plotted and drew a line. I told you guys in class that if you make a mistake in your calculation, any 2 points that you draw, you can make a straight line through. It just may not be the right line. So again, to be safe, when I'm taking a quiz or a test and I've got a graph, I'm not going to just leave it to 2 points. I'm going to pick a 3rd point and make sure that my line is actually correct. Okay, let's go to the next page. So we're going to talk about perfectly horizontal and perfectly vertical lines. When we first started Unit 5A, we had our slope man, and we said that a perfectly vertical line, this was his nose, is undefined, and we had a perfectly horizontal line for the mouth, and we said that slope was 0. And we've talked about it throughout 5A, B, C, but we're going to go ahead and formally have a section to give you some good notes on that. So the points on a horizontal line have the same y coordinate. So if you were to plot a perfectly horizontal line, I'll just pick one right here, horizontal line, and let's say that point is 3. Every single x is going to have its y coordinate be 3. So horizontal lines have a different x, but they have the same y. The equation of a horizontal line is y equals whatever number it's cutting through the y-axis at. So in this instance, the equation of this line is y is equal to 3, and there's no x associated with it. Vertical lines, of course, are the opposite. They have the same x coordinate. So if you have a vertical line and it passes through this point right here, let's call it 3, then every single y is going to start with 3 as an x, because you're going to go over 3, and then you're going to go up or down depending on what your y coordinate is. So the equation of a vertical line is x equals whatever number it cuts through on the x-axis. So these 2 special lines don't have both an x and a y as part of their equation. They have just one variable. So if this, I don't even know how you say all this. If this helps you remember it, fine. But H stands for horizontal. H-O-R-Z-O-N-T-A-L, horizontal. The slope is 0. Horizontal lines have a slope of 0, and it is a y equal some number equation. So I guess maybe we could say Spanish, hoy. I don't know how you would say V-U-X, bucks, I suppose. Let me go get another color. I'll get the blue guy. So this, of course, stands for vertical. Its slope is undefined, and it is an x equals some number equation. So we got a couple examples that we're going to do really down at the bottom of the page. It says write an equation for each line described. So we're going to write it and we're going to graph it on this one graph. So a vertical line through this point right here. So if it's a vertical line, we are only looking at the x coordinate. X equals 4 is the equation of the line. And here it is, 1, 2, 3, 4. And it's a perfectly vertical line. And if they asked us, we could say, well, the slope is undefined. Horizontal line, we're only looking at the y. So it is a y equals 7 equation. So here's 7, where it cuts through the y-axis. And that's what that equation of the line looks like. All right, last example on this page, write an equation for each line described. Zero slope, so we know we're looking at what kind of line? A horizontal line. It's a perfectly horizontal line through the point 2, 1. Well, let's go over 2, up 1, and the only perfectly horizontal line we can draw looks like this. So once again, it cuts through the y-axis at 1, and it has a slope of 0. The last one is an undefined slope so we know it's going to be vertical, perfectly vertical, through the point 2, 1. And this is so this was a y equals 1 equation, and this is going to be an x equals 2 equation. So we are going to go where x is 2, which is right here, and we're going to draw a perfectly vertical line through x equals 2. So these are some special exceptions. These are a little bit different than the ones that have both an x and a y in there, but you'll just want to be looking for perfectly horizontal and vertical lines. Thanks for watching. We are done with 5D.